So before we begin, we'll just do a few introductions. My name is David Grant, and I'm a member of the professional services team here at Aculab. If you have any technical questions after the webinar, then you can contact myself or another member of my team by emailing presales@aculab.com. And to introduce you to the account managers here at Aculab, in the EMEA sales region, we have 4 account managers: Martin, Mark, Walter, and Ina. And covering the American region, we have John Kozlowski and David Ziebelman. And if you'd like to get in contact with them after the webinar, you can either, if you have their email addresses, use those, or email sales@aculab.com. So before we go through the technical side of the webinar, I'm just going to quickly recap what was covered in our last webinar for those who did not attend. But also note that this webinar is available for you to download on the website as well. So who are Aculab? Well, Aculab have been innovating within the technology industry, telephony, for over 30 years, providing a competitive advantage to our worldwide customer base. I expect a number of you will know Aculab as a manufacturer of E1 T1 cards or voice boards, and this is certainly true. Aculab has developed telephony solutions that can be run on board, on host processor, and now on cloud-based platforms. Whatever your preference, at Aculab, we're a wealth of technical experts ready to help you through design, building, and supporting your telecom solution. So what are the main objectives of a telephony application? Well, they're to make or receive a call and to allow you to interact between callers or a caller and an application. They should be there to improve customer services, reduce costs, and improve efficiency within the business. Now, to drill down a little deeper, the functionality you would expect within a telephony application, you'd expect it to be able to answer or place a call, voice or fax, play prompts or menu and announcements. Now, those could be either pre-recorded prompts or using something like text-to-speech. You'd expect it to be able to detect digits for user input, transfer or connect calls, perform call progress analysis, and also add users to callers' conferences, start recording, and at the end of it, obviously hang up the call. In the past, these functions and features were provided by hardware or software in a computer server based on a customer premise, with applications programmed using low-level C APIs by developers with an in-depth knowledge of telephony. Aculab Cloud enables you to rapidly develop applications with these functionality features using a high-level Python or .NET API without the need for costly on-premise telephony equipment. So let's look at what Aculab Cloud provides you with. It provides you with international dialing for inbound and outbound PSTN calls, or you can make your own inbound and outbound SIP calls or use your own PSTN providers. We provide you with the telephony resources for performing replay, recording and conferencing and fax and things like that, and also access to text-to-speech technologies. We also provide you with storage for pre-recorded prompts or call recordings. On-premise, you just have your application running on a server and any databases or data required to run and interact with your application. But that application, and in fact the database, could also be placed on your own cloud servers if you wish. So let's see how we fit together. A number of people have asked whether we're now competing with our customers, and the answer to that is no. We're providing a telephony platform hosted on Amazon EC2 infrastructure, which can be used to rapidly develop either end-user applications or development toolkits. Another way of putting it is that we provide the high-level APIs and infrastructure for rapidly developing and deploying telephony applications. Shortly, I'll be showing you how quick and easy it is to develop one of those applications. Now I'm going to show you a short video which explains how the interaction between your application and Aculab Cloud works. So as we saw in that short video, your Aculab Cloud application runs on a server of your choice external to the Aculab Cloud resources. This could either be on customer premise, or as I mentioned before, on your own cloud servers. The applications are managed and executed by some software running on your server called the User Application Server. This server is administered through a web browser and is also used to manage connections to cloud regions, because we have cloud telephony resources located in both Europe and America. It's also used to retrieve logging when debugging cloud applications. And as I mentioned, the applications that you're running are also managed and executed by this software. Now, these applications are themselves not doing any heavyweight processing. They're just running application logic which tells the telephony resources what to do, such as play a prompt, detect DTMF, or transfer a call. The UAS software is downloaded through the Aculab Cloud website at cloud.aculab.com, and once installed, you connect to it through your local computer by going to the local address. Currently supported programming languages are Python 2.6 and 2.7 and .NET framework. Coming soon are a Java API and also a RESTful web API. So the User Application Service is used to manage the applications located on your server that you wish to use as cloud telephony resources. When a call comes in, the cloud needs to know which application to run and you need to assign an application to a PSTN or SIP number to do this. And this is done by the Cloud Web Portal. So as well as managing inbound and outbound services, the Cloud Web Portal is also used to manage and provision PSTN numbers, manage media files, so those could be replays or recordings, access usage reports such as CDRs, and also manage cloud usage credit. And all these features are accessed through the cloud.aculab.com website. And this is also where you sign up for a free developer account and view documentation. So we're now going to go through creating a free Aculab Cloud developer account, show you where to download and how to install the user application service, and also create our Hello World cloud application, our first cloud application, answering an incoming call, playing a text-to-speech prompt, and then hanging up the call. Just bear with me as I share my desktop. So when you go to cloud.aculab.com, this is the first thing you'll see. And to sign up for a developer account, you just have to go there and click on Sign Up. You just have to choose the region, whether you want to create an account on the European or American cloud. Just enter an email address, which is your username, password, and some contact details. Once you've done that, you'll be sent an email which you can use to confirm your and authenticate your sign up for the account, and then you'll just be able to sign in. So I've already got an account, so I'm going to go and log in. This is the first screen that you see when you log into your account. You see you've got some usage statistics here, as well as access to documentation, software downloads, and the Quick Start Guide. And the Quick Start Guide is the best place to start. It takes you through where to download the UAS software. So you've got to decide obviously whether you want to use .NET or Python, and then there's a link there to click and download the software. So once we've downloaded the software and installed it, it's just a normal Windows install package, or on Linux it's a zip file that you extract and install. Once we've done that, we need to check that the software is installed correctly, and to do that we can log into the UAS management console. So you just go to localhost 38,000, and we use the same login details as we provided for our cloud account. So here's the user application server, and as I mentioned, we've got an area that tells you the clouds that you're connected to. As you can see, I'm connected to both the European and US clouds, and you also have a tab that shows the applications that you've installed on your user application server. So now what we'll do is we'll look at creating our first application. And today we're going to look at using C# for this. So what we want to do is create a new project. And we handily provide you with some templates for creating both an inbound and outbound application. So we're going to create an inbound application, call it Hello World. And here's the code. So as we can see, we've got a class called Hello World, and it inherits from this UAS inbound application. We just have to implement this run method, which is basically where the call flow for our inbound application is. So here we're doing channel.answer, which basically answers the call for us, and channel.fileplayer.say, which is going to say some text for us. So we're going to change this text. Hello world, this is my first cloud application. As you can see, here it's saying channel.wait for idle. It's basically waiting for the caller to hang up. But we're going to change this. We're going to hang up the call ourselves. And we simply have to say channel.hangup. Now we're going to save that project, build the project, so then it's built, and now we need to load it up onto our user application server. We just go install application, choose the file that we want to install, and it's in C#, it's a DLL, it's hello world.dll. So now it's installed. So if we go back to our cloud web portal, I'll just show you the inbound services. And I've also already added to my my developer pin service my Hello World application. So I have to click in here to show you. All I've got to do is give it the name of the application, and that's it. And with your developer account, you get numbers that you can call to test your application. And so you call that number, type in the developer pin code, and that application will run. So I'll do that now.
Hello. Please enter your 8-digit private developer PIN code on your telephone keypad.
Go into my
If you
PIN
make a
code.
mistake, just type star to check. Thank you. Please wait while I connect your call. Hello world. This is my first cloud application.
There we go. It's we've dialed in, entered our developer PIN code, and it's run our application for us and hung up the call. So as you can see, it's as simple as that. And if we wanted to change the application, change it to saying, hello world, this is my second cloud application. All I have to do is rebuild the project. Reinstall the application, and then dial the number again.
Please enter your 8-digit private developer PIN code on your telephone keypad. If you make a mistake, thank you. Please wait while I connect your call. Hello world. This is my second cloud application.
There you go. You can simply change the application as you go and easily retest it very quickly. So now we're going to look at a slightly more complex IVR style voicemail application. The application will answer an incoming call, play a welcome prompt to the caller, ask the caller to press 1 to record a message or 2 to replay a message, and if they press any other digit, replay the menu options. Those of you who are familiar with Aculab's low-level C APIs may recognize this example from the example code provided with the normal Aculab software installation. However, where this cloud app, where the normal example code takes over 5,000 lines, this example is only 125 lines of code. We should remember the low-level C APIs do still have their place. For example, when you're creating a gateway to connect between disparate networks, or when you need to connect directly to the telephony network to gain access to low-level protocol-specific functionality. However, as you can see, the high-level cloud APIs enable you to develop complex call flow applications quickly with little or no telephony knowledge. So now we're going to look at the IVR voicemail example. As you can see, again, we're inheriting from the UAS inbound application, and we're re-implementing the run method. So here, we make the call ring for 2 seconds, so the user feels that they're calling into an application, and then we answer the call. We'll then use fileplayer.say to welcome the caller to the voicemail system, and then we ask them for some DTMF input. So we say press 1 to record your message or 2 to replay your message. And then we do channel.dtmfdetector.getDigits to retrieve the DTMF input. And we just said we want to get 1 digit, and we'll wait 10 seconds, and if the user hasn't input anything after 10 seconds, then we'll return. So if the digit returned is 1, then we'll record a message. If it's 2, we'll replay a message. So looking down at the record method, we'll play a prompt, asking them to record a message, again using fileplayer.say, and then to perform the record, channel.filerecorder.record, and we just have to pass in a file name where we want the file to be recorded and the type of recording, so we're doing an ALAW recording. But it's just one line of code to perform a recording, whereas in the low-level APIs, you'd have maybe 30 or 40 lines of code, if not more. And then to replay the file, again, we just give a prompt to say, and then replay the file by saying channel.fileplayer.play. So if we look at the inbound services, this time I've got a dedicated number for the voicemail application. There it is. So if I dial that number, then I can test the voicemail application.
You land web in a voicemail system. Press 4 to record your message. Press 2 to replay your recorded message.
So if I press 1,
Please record your message after the beep.
hello, this is testing the Aculab voicemail system.
Press 1 to record your message. Press 2 to replay your recorded message.
Hello, this is testing the Aculab voicemail system.
Press 1 to record your message. Press 2 to replay your record.
So you can see we dialed into the application and we were able to leave a message and then replay the message that we'd left. So it's shown you a simple IVR application that can be written in a few lines of code. And as you can see from this list, the cloud APIs can be used to write a wide range of telephony applications. We'll now go through some other cloud usage examples. One of them is voice broadcasting. Very good use of cloud telephony, where you want to send a simple message to a large volume of callers in a small space of time. With cloud, you do not need to provision equipment for those peaks in traffic volume. So if you want to run a voice campaign, you have a database where you pull your contacts from for the voice broadcast. And then Aculab Cloud executes your application, making outbound calls and playing your customer message. And thousands of calls can be made within minutes. One of our customers already using this is Alert Solutions, which is used within schools and universities to notify staff and parents when incidents take place, or when a school is closed due to bad weather, such as snow. Another of our customers using cloud technology for voice broadcast is eClinicalWorks, who use voice broadcasting within doctors' surgeries and hospitals to perform appointment reminders and let customers know when test results are ready. As we saw with the voicemail example earlier, IVR is another example of using cloud telephony. A customer makes an inbound call to a customer service. Aculab Cloud routes the call to the IVR app based on the number called, and then the caller may use DTMF input to opt to speak to an agent, and then the system makes an outbound call to the agent and connects the customer and the agent together. A customer already using this is BQuick Software, a large billing company who use an inbound IVR solution so that customers can register their new prepaid mobile phones before use. Another use would be conferencing, where conferences can scale from 2 to over 200 people. The conference delegate calls in to a conference grid. Aculab Cloud routes the call to the conference application based on the number called. The caller enters details, and then all conference parties are transferred to a conference room and conference together. One of our customers who uses this is MeetFM, who use cloud conference platform as a part of a collaboration suite to provide both SIP and PSTN audio access to meetings and document sharing. They moved to our platform for a number of reasons. One, because their other cloud provider could not provide them the large-scale conferences they required, which was more than 40 participants per conference. They also liked the wide range of countries to which we could provide PSTN numbers, which allowed them to expand to places like Australia, which were they unable to previously do. One question that has often come up is the resilience of cloud-based solutions. Aculab handles the resilience of the cloud telephony resources themselves, but people often wonder how they can improve the resilience of their application servers. This can be best explained by looking at a working call followed by a failure scenario. So during normal usage, a customer makes a call, an inbound call to the cloud, and Aculab Cloud routes the application based on the number called for your UAS. But if your UAS goes down for any reason, the customer makes a call in, and the UAS is unable to connect and route the call. So how do you resolve this? Well, by having two user application servers. So if one goes down, customer makes a call, and it's routed to the UAS that's currently working. And if both UASs are up, we can improve resilience and by load sharing between the two UASs. So in conclusion, Aculab Cloud provides an easy-to-use, high-level API, either Python or .NET, which can be used to develop applications, and the developers need little or no telephony experience. You can use Aculab Cloud to integrate telephony functionality into many applications and use third-party libraries for database and other connectivity. We provide a free developer account and example code to get you going, along with email technical support. Aculab can also provide consultancy for development of cloud applications if you so wish. So thank you for attending. I will now open the floor to any questions you may have. So one question that's come in was asked, what's the maximum number of conferences that you can have? And as I mentioned previously, it's over 200 per conference room. Now, normally you would the maximum you can normally have is 40, but if you want greater numbers than that, then you've got to pre-provision the conference room with the maximum parties before the conference takes place. But that only needs to be 5 or 10 minutes before the conference actually takes place. So if anyone's got any more questions? So just had a question about how to handle pre-recorded voice files. The pre-recorded voice files can be loaded up to Aculab Cloud, and then you basically play them from there. If you just bear with me. If we look at the voicemail example, the channel.fireplayer.play is playing a voice file. So that'll be a pre-recorded voice file. In this case, it's a recording that we've made up on the cloud, but you know, it could quite easily be a pre-recorded file that you have uploaded to the cloud as well. Distributing calls to agents is not automatically handled by the cloud, but it could be easily written into a cloud application using a database of agent numbers, and those agents could be hanging off the cloud either as SIP agents or PSTN. So another question has come in asking where you host the user applications server. This can either be hosted on your premises, just as you know, a normal network computer, or you could host it within your own cloud services. So if you had an account on somewhere like Amazon EC2. But for an example, I'm running my user application service for these test examples on my laptop here. Just had a question about licensing. there are no licensing needs involved in the use of Aculab Cloud. Obviously, you've got the charges for the use of the platform, which are 1 cent a minute for usage of platform time. But as far as licensing concerned, there is no licensing needs. Okay. And another question has come in about clearing causes when a call fails. You do get some clearing causes, but not specific ISDN clearing causes. And I can also provide some documentation on that to you about that one. Just had a question about using the UAS on Linux, and it shouldn't matter what flavor of Linux you're using for running the UAS, as long as you have either Python 2.6 or 2.7 installed, then that should be fine. Right, we've had a question about getting usage reports from Aculab Cloud. Currently, usage reports have to be downloaded through the web interface, but there are plans for an API to allow you to download the usage reports within your application. Another question has come up about payment for cloud. So basically, you have cloud credit, and it's basically pay as you go. As far as, so when you're not when no one's calling in, you're not paying for usage of the system. It's only when someone makes a call into the platform that you actually pay for usage. The recorded files, we've had a question about that. Basically, recorded files are saved on Aculab Cloud, and with the developer account, you have 100 meg of free space for storage of files, and more if you have a deployment account. So basically, any recorded files are stored within Aculab Cloud, and that's how the applications access them. There's also an API for uploading and downloading files from Aculab Cloud. With regards to storage of those media files, no external storage is required. As I sort of mentioned just now, with the developer account, you get 100 megabytes of free storage of audio files, and with a production account, you get 1 gig of storage. Okay, we'll stay on for a couple of more minutes if anyone has any more questions. So we've just had a question about making SIP calls into the cloud. If you bear with me, I'll just show you. Good way to show you is with the developer account example. So if we look here, this is the SIP URI that's associated with my my developer account. So if you called that URI, you would be able to dial in over SIP, and so you can create other SIP URIs to dial in, but those have to be created and assigned to an inbound service rather than being created on demand. Thanks everyone for joining and attending the webinar. And if you have any more questions, then just email them through to presales@aculab.com, and myself or one of my colleagues will endeavour to answer them. Okay, thanks a lot.